What is core-type transformer? Imagine you have a special racetrack made of iron. This racetrack isn't for cars, it's for something invisible but incredibly powerful called magnetic flux. In a core-type transformer, this iron racetrack is the magnetic core. It's not just one solid piece of iron, though. To make it work best and reduce energy loss, it's usually built up from many thin sheets of iron stacked together, like pages in a book. Now, this core has a specific shape. Think of it as having two main straight parts standing upright. We call these limbs. These limbs are connected at the top and bottom by horizontal sections called yokes. So, you have got this closed loop, this magnetic pathway made of the core. Next, we need the parts that actually handle the electricity, the windings. These are coils of insulated copper wire. In a core-type transformer, these windings don't go inside the iron core. Instead, they are wrapped around the limbs of the core, like thread around a spool. Here is a neat trick. If we have a primary winding, the one we connect the initial electrical power to, and a secondary winding, the one that gives us the transformed voltage, we don't put the entire primary and the entire secondary on just one limb. Instead, we split them up. Half of the primary winding and half of the secondary winding go on one limb, and the other halves go on the other limb. Why do we do this? Well, it helps to make sure that most of the magnetic field created by one winding nicely links up with the other winding. This minimizes something called leakage flux. Think of leakage flux as some of the magnetic field lines going astray and not doing their job of inducing voltage in the other coil. By splitting the windings across both limbs, we keep the magnetic connection strong and efficient. This core around the windings design has some really good advantages. First off, assembling these transformers is generally simpler. It's often easier to wind the coils separately and then carefully place them around the core limbs. Also, having the windings wrapped around the core can make it easier to provide good insulation between the electrical wires and the core itself, which is important for safety and reliability. Secondly, because the windings closely surround the magnetic core, the magnetic coupling between the primary and secondary windings is really good. This strong coupling means that the transformer can transfer energy more efficiently, wasting less power as heat. So, you get more out of what you put in. Thirdly, if something needs fixing or checking, maintenance is often easier with core-type transformers. The way they are put together can make it simpler to take them apart and put them back together again. Finally, the design allows for pretty good natural cooling. Because the windings are on the outside, they can lose heat more easily to the surrounding air. While big, powerful transformers might need extra help with cooling like oil and fans, the basic core-type design helps with heat management. So, where do we find these core-type transformers in the real world? They are workhorses in high-voltage applications. You'll see them in distribution transformers, which step down the high voltage from power lines to the lower voltage that comes into your homes and schools. They are also used as power transformers in substations and even as auto transformers, which are a special type that uses a single winding for both the primary and secondary circuits. In a nutshell, the core-type transformer, with its iron core providing a clear path for magnetic flux and its windings snugly wrapped around it, is a fundamental piece of equipment that helps us safely and efficiently manage and use electrical power, especially at higher voltages. It's a clever design that balances performance, stability, and ease of upkeep.